Today we're going to get into graphing square root functions. So the parent function of a square root equation is y equals square root of x, or you could say f of x. That's the same as y equals, that's it. Cool. All right. So details, the graph starts at blank and moves blank, blank, blank while moving to the blank. All right, now let's look at our chart first and then we'll kind of see some stuff. Now we have to pick numbers for x that we can square root. We can't square root negative numbers. The smallest number we can square root is 0, and the square root of 0 is 0. What other positive numbers can you square root? Well, the square root of 1 is 1. The next number I could square root is 4. We're thinking of our perfect squares. The square root of 4 is 2, and another one would be the square root of 9 equals 3. So these would be 4 coordinates that would fit on our square root function graph. So 0, 0, 1, 1, 4, 2. That's all that's going to fit on this graph. A lot of times you have graphs that go 10 by 10. So you would put the 9, 3 on there as well. These are like the starting points. So our graph starts at 0, 0 and moves up slowly while moving to the right. Look at that. It's like a nice gentle sledding hill over here. So these are like, memorize these points. Numbers you can square root. 0, 0, 1, 1, 4, 2, 9, 3. Starting points. Use them a lot. And then we'll have some transformations. We'll shift it up, down, left, right. Describe what's happening from the dotted line to the solid line. So our dotted line is that square root function. What's the difference with the solid line? Well, it's every coordinate is shifted up 3 units. Up 3. Cool. Describe what's happening from the dotted line to the solid line on this one. Well, it's the same thing, but everything's shifted left 3 units. Oh man, if only there was like a general equation that we could determine the up, down, left, right shifts. Oh my goodness. You wouldn't even believe what's on. Here it is. Y equals the square root of x minus h plus k. Now, very similar to when we graphed quadratics. The shifts are the same. When it's grouped in with the x, that's our horizontal shift, our left and right. Now that one kind of feels like it's the opposite. Left or right. Now, it's crazy because if it says minus some number, you actually shift it right that many units. So if it says minus h, you shift to the right. If it says plus some number there, you're going to shift it left. The k is the number being added or subtracted outside the radical. This is your up and down shift, and this one actually makes sense to me. So you're going to shift up if it says plus k, and you're going to shift down if it's minus k. That one makes sense in my head. So let's start graphing some stuff. I find it very helpful to draw the original parent function on there. First thing you do, and you're going to do a lot of these, so you're going to memorize those points. Remember, we had 0, 0, 1, 1, 4, 2, and then 9, 3. So go ahead and put those coordinates on all your graphs real quick. That's our parent function. It's where we're starting off. So example 1 says f of x, y equals square root of x minus 3. It has that minus 3 and it's not grouped in with the x. That's your up and down shift. So this is just going to take our exact graph and drop it down 3. So take your coordinates and just go down 3. Here's 0, 0, drop it down. 1, 1, drop it down 3. Here, drop it down 3, drop it down 3. And we're having fun. Look at us having so much fun. We are going to do domain and range for this. This is a little trickier than the quadratic graphs. Remember, domain is left and right. Now what's the furthest left our graph ever hits? The furthest to the left it goes is 0. So we're going to say that x has to be greater than or equal to 0. Cool. The y's are your range, your up and down. The lowest this ever hit was -3, and then it goes up forever, even though you can only see it go up to like 0. But if this was zoomed out, it would keep going up slowly. So everything has to be greater than or equal to -3. Sick. All right, hop over here. This one has the -3 grouped with the x. That's your horizontal shift. So this is going to take all our coordinates and go to the right 3. So we'll take our 0, 0 and go right 3. 1, 1, go right 3. Take this coordinate, go over 3. That's all that's going to fit on the graph. This changes our domain because what's the furthest this green line ever hits left and right? The furthest it goes to the left is at 3. So we're going to say x is greater than or equal to 3. Domain is up and down. Still, the lowest this one hits is 0. So we're going to say y greater than or equal to 0. Pretty fun. We should probably have some problems where we're throwing in multiple transformations. Oh my gosh. This is it. But again, let's draw our parent functions on there on both graphs real quick. 0, 0, 1, 1, 4, 2, 9, 3. 0, 0, 1, 1, 4, 2, 9, 3. All right, example 3, we have square root of x minus 1 plus 3. The minus 1 will shift it to the right 1. The plus 3 will shift it up 3. So with each one of these points, we're going to go right 1, up 3. 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 Wow. All right, let's do our domain and range. Domain is left and right. What's the furthest left this goes? The furthest left it goes is +1. Everything else is greater than that. So we'll say x is greater than or equal to +1. The y, the range is your up and down. The lowest this hits is +3. Everything else is above that. There we go. All right, here we are. This one's got 2 shifts as well. The +4 is going to shift it left 4. The -2 is going to shift it down 2. So all of our coordinates, we're going left 4, down 2. 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 Wow. All right. So if domain is our x's, our left and right, the furthest to the left it goes is -4. Everything else has to be greater than or equal to that. Up and down is the range. The lowest this hits is -2. Y greater than or equal to -2. That's it, man. We're done today.